For basically all of human history, when we wanted to build something big, we did one thing: we built up. But what if that's all wrong? What if the smartest, safest, and strongest way to build a skyscraper isn't to fight gravity, but to use it as a tool? Okay, let's get into this, because it's a wild ride. The idea of building down.
Just picture any construction site you've ever seen. It's this epic brute force war, isn't it? We use these massive cranes and just burn incredible amounts of energy to haul steel and concrete into the sky, fighting against the most powerful, constant force on Earth. It's inefficient, it's super dangerous, and what if it's all completely backwards? Okay, so this slide just lays it all out, plain and simple. On the left, you've got the old way. Fighting gravity, putting people in harm's way, dealing with wind and rain. It's a struggle. But now look at the right. Building down completely flips the script. You actually use gravity, which is amazing. You get people out of the danger zone entirely, and you're building in this perfectly stable environment underground. We're not just talking about a new method here. This is a whole new philosophy.
So, you're probably asking yourself, how on earth is this great inversion even possible? Well, it all comes down to a single piece of technology that completely reinvents what a construction site even is.
Right, so first, just erase that mental image of a sprawling, chaotic construction site. No cranes, no scaffolding, no armies of workers. Forget all that. The entire job is done by one single autonomous machine. Think of it like a massive tunnel boring machine, but instead of going sideways, it's pointed straight down. It digs its way into the earth, and as it goes, it builds the finished building in its wake.
And this is where the real genius kicks in. It's not dig, then build. The whole thing is fused into one seamless process. As the machine goes down, it's literally printing the final, perfect structure right behind it. And the best part, the absolute secret sauce? Gravity does all the heavy lifting for you. All the materials, concrete, polymers, you name it, are just fed down from the surface through simple channels. No more cranes, no more burning insane amounts of energy just to lift.
Now don't go thinking this is just some big dumb drill. Oh no, this machine is incredibly smart. And the brains of the operation, well, that's a concept that takes 3D printing to a whole other dimension. It's called 6D printing.
So to really get this, let's do a quick level up. We all know 3D printing, right? That just gives us geometry. Then came 4D printing, which added time. Think of materials that can change shape after they're printed. 5D printing brought in optimization, making things as strong and light as possible. But 6D printing, that's the quantum leap. It adds live sensing and real-time response. The machine isn't just building, it's aware. So what does aware actually mean? It means it's a closed-loop system. It isn't just blindly following a blueprint someone programmed months ago. It's constantly taking in data from its surroundings and making smart decisions on the fly. It's adapting and optimizing every single layer as it's being printed. It's basically thinking as it builds.
And what's it sensing? Oh, just about everything. We're talking ground pressure, tiny little seismic shifts, the moisture in the soil, even temperature changes. And this data isn't just for a report later. It's used instantly. So if the system feels a bit of extra pressure on one side, boom, it immediately adjusts the concrete mix or adds more reinforcement to that one specific spot. This constant feedback loop means you don't just get a building, you get a structure that is perfectly evolved for its exact spot in the Earth's crust.
All right, so that's the how, this super smart machine that prints its way down into the ground. But now let's get to the why, because this is where the advantages of this whole thing just become, well, game-changing.
Let's start with the most important benefit of all, people. Human safety. I mean, let's be real. Conventional construction is one of the most dangerous jobs out there. This method, it takes people out of the high-risk environment entirely. And there's this quote from the source material that just hits the nail on the head. The fact that no humans are on site during the build isn't some happy accident, it's not a side effect. It's a core advantage, a foundational principle of the entire design. Safety is literally the starting point.
And this chart, wow, it just lays out the difference. And it's night and day. Human safety goes from high risk to zero risk. Seismic stability, instead of fighting an earthquake, the structure literally moves with the earth. The lifetime energy use is slashed, and the materials last way longer because they aren't getting blasted by sun and rain. You go down the list, and it's just a clean sweep.
This visual right here tells a huge part of the story. You see that giant bar? That's pretty much all the energy we waste just fighting gravity, just lifting stuff up. By letting gravity do the work, that massive energy cost just vanishes. All you're left with is the energy to dig and precisely place materials, which is tiny in comparison.
And structurally, it's not even in the same category as a normal tower. A traditional skyscraper is basically a giant lever, focusing all its stress on a tiny foundation. This subterranean structure, though, it transfers its load outwards into all the surrounding rock and soil. It becomes an integrated part of the geology. So it's not really a tower at all. It's more like a man-made mountain.
Okay, so let's zoom out, because the potential here is way bigger than just one building. This technology could fundamentally change how we design our future cities. I mean, just imagine it. We could add massive amounts of space and density to our cities without ever changing the skyline. We could leave the entire surface for parks, for nature, for people to enjoy. We could build our most critical infrastructure, data centers, transit hubs, power grids, deep underground, completely safe from hurricanes, heat waves, anything. It's urban growth that's completely invisible.
When you get right down to it, what we're talking about is a huge philosophical shift. The source material calls it a redefinition of architecture as a geological process rather than a mechanical one. We'd stop forcing these giant machines onto the planet and start weaving our structures into the planet.
And that's the key takeaway here. This might sound like something out of a sci-fi movie, but the more you think about it, the more it feels, well, inevitable. As our tech gets smarter, as our need for resilient and sustainable cities gets more urgent, building down just becomes the most logical path forward. It's about finally aligning our engineering with the laws of physics instead of against them.
So, this all leaves us with one really profound thought. For our entire history, our greatest achievements in architecture have been monuments to our fight against gravity. By finally choosing to work with it, we unlock all these possibilities we're just starting to imagine. And it really makes you wonder, what's the next fundamental force we're all needlessly fighting when we should be working with it instead?
Okay, so before we get to all the cool futuristic stuff, we've got to take a step back and look at how we used to do it. And honestly, the old way was, well, it was kind of genius in its own right. We're talking about a method called free fall casting. And this is what's so cool about it. It's brilliant because it's so simple. You literally just use gravity to do all the hard work. You dig a shaft and then you just drop the concrete in. I mean, how elegant is that? It's the Earth itself doing the heavy lifting to build the foundations of our world, right? You're just harnessing a basic force of nature. That means you don't need a ton of complex, expensive machinery. It was super effective for building deep foundations, and for its time, it was pretty safe too. This was the gold standard for a long time. But, and there's always a but, isn't there? This is where the old method kind of hits a wall. Literally. It was ingenious, for sure, but man was it slow, and it took a ton of people to get it done. The real problem though, when you tried to build something really, really big with it, the costs just went through the roof. It just wasn't scalable. So it was clear we needed something new, a better way. So what's the solution? Well, you don't just tweak the old system. You have to throw it out and start over. We're talking about a complete revolution. The answer wasn't just a small improvement, it was a total shift in thinking, moving away from human power and embracing automation. And this is it, the game changer. What you're looking at is the idea of a mega boring machine. We're talking about a massive, fully autonomous machine that drills deep into the Earth. And get this, it's powered by its own onboard nuclear reactor. I know, it sounds like something straight out of science fiction, but this isn't a movie. This is where construction is heading. Okay, now this is where it gets really mind-blowing. Think about the old way. You dig a bit, then you stop and reinforce it, then you build a little, step by step, super slow. This new machine, it does all of that at the same time. It excavates, it reinforces the walls, and it builds the final structure, all in one continuous process as it moves downward. It's not just a drill, it's a mobile factory, 3D printing a building into the ground. And since it's fully autonomous with its own power source, it just doesn't stop. It works 24/7, no breaks, no shift changes. Think about that. The entire need for huge crews of people working in dangerous conditions deep underground, gone, just completely eliminated. All right, so we've got the clever old way versus this brand new futuristic game changer. Let's actually put them side by side, a little face-off so you can really see just how massive this leap forward is. And wow, just look at this breakdown. It's not even a fair fight, is it? Labor goes from entire crews to zero. The process goes from sequential steps to doing everything at once. Speed, power, scale. I mean, in every single metric, the mega boring machine is just on another level. This is an upgrade, it's a total reinvention of the whole process.
But hold on, it gets even better. Beyond just the raw power and the incredible speed, this new method has a secret weapon. A truly brilliant feature that's built right in from the start. It's something the old way couldn't even imagine.
Water, a built-in gravity-fed water system. As the machine is building downward, it simultaneously installs a system to bring in filtered ocean water. So from day one, the structure has its own limitless water supply. And the best part? No pumps, no electricity needed. Gravity does all the work for free. That is just genius.
Okay, so it's faster, it's more efficient, it's even self-sustaining with water. But what about the bottom line? What about the money? Well, this is where the whole thing goes from cool idea to absolute revolution. Let's look at the economics.
And this quote really says it all, doesn't it? The cost savings are extraordinary. We're not talking about saving a few percentage points here and there. The word extraordinary is used for a very, very good reason.
Just look at this graph. It's so simple, but it tells the whole story. The cost of a traditional project is that huge bar on the left. The cost with this new automated method, it's that tiny bar on the right. The difference is just staggering. It means projects that were pure fantasy because they were too expensive are now suddenly on the table.
So where do all these savings come from? Well, it's a perfect storm of efficiency. First, you wipe out human labor costs. Poof, gone. Then you shrink the construction timeline from years to months, which saves a fortune on financing. Plus, the machine uses materials with robotic precision, so there's almost no waste. It's a top-to-bottom optimization of everything.
So when you put it all together, the insane new technology and the incredible cost savings, the potential is just hard to even wrap your head around. We're not just talking about building deeper foundations anymore. We're talking about building entire habitats, whole cities right under our feet. And this is maybe the best way to think about it. Picture a skyscraper, all of its floors, its infrastructure, its sheer scale. Now, just flip that image upside down and have it plunging deep into the earth. That's the kind of vision this technology makes possible. And I want to be clear, we're not talking about fancy basements here. We are talking about true megastructures. We're talking hundreds of meters deep, with everything you'd need to live, work, and thrive down there. And that's really the bottom line. This isn't just a cool piece of engineering. This technology takes the idea of massive underground cities from science fiction to practical reality. It makes them efficient, affordable to build, and totally sustainable. So here's where we land. The tech is basically here, the engineering problems are being solved, the economics make perfect sense, everything is lining up. The only real question left is, are we ready for it? Are we ready to start building our future not by reaching for the sky, but by digging deep into the earth? It's a pretty wild thought.